Hello. In this screencast, we're going to discuss titration, what it is and what it's used for, um, the technique, how to perform it, and then at the end we're just going to discuss some calculations. So first of all, what is titration and what is it used for? Titration is a technique that is used to determine the concentration of an unknown solution by using the concentration of a known solution, and we'll discuss this further as we go along. So what are the objectives of titration? There are two main objectives of titration, and these include, first of all, determining the concentration of a standard solution of sodium hydroxide by titrating it against a primary standard. And in this case, the primary standard that we're going to be using is potassium hydrogen phthalate, which is KHC8H4O4. And the second objective is to determine the concentration of an acid solution by titrating it against the standard solution of sodium hydroxide. So definitions to know when performing these titrations. Definitions of primary standard are substances whose precise mass can be determined using a balance and can be dissolved in water and then reacted with the substance to be analyzed. A standard solution has a measured number of moles and a measured volume. In other words, it is a solution with an accurately known concentration, usually expressed in molarity of the solution. And the solution is standardized using the primary standard, and then the solution is used to react with the substance being analyzed. So the titrant is a standard solution of sodium hydroxide, which has been standardized using the primary standard potassium hydrogen phthalate, and the analyte is a substance whose chemical constituents are being identified and measured. And then lastly, the endpoint is the point at which the phenolphthalein turns color, so in this lab it'll turn a slight pink. Now we're just going to review some key concepts of titration. So the key concepts of the titration procedure: first you want to prepare the primary standard acid, and then you want to dissolve that acid in solution. Then you prepare and fill the burette, and next you place the Erlenmeyer flask with the acid solution under the tip of the burette, and you place a white sheet of paper under the flask just to make sure that you can see the color change once it's titrated. So you titrate the primary standard. This just gives a rough estimate, so that you can then measure out the base more precisely. And then you refill the burette with that base NaOH and you record your initial volume. Once you've carefully titrated the primary standard, then you can record the final volume of NaOH in the burette. And then you're ready for calculations. Next, we're going to look at how to get reproducible data. And so for this, the general procedure: let the solution out of the burette slowly, stopping frequently to let the color of the solution in the flask dissipate. Once the color disappears, continue to let the solution out of the burette, still stopping frequently. And when a slight pink color forms and lasts for approximately 30 seconds, then you know you've reached your endpoint. So the first trial is usually a rough estimate, as I said before, because you usually go past the endpoint during that first trial because you're still figuring it all out. So once you've done that, then you can be more precise with your other trials. So now that you know about when the endpoint is, you can be more careful when you're beginning to reach that endpoint so that you make sure you're not going to go over it, and this makes it easier to stop closer to the endpoint, producing more accurate data because you're aware of that endpoint. And just something to note real quick: you know you've reached your endpoint because, as we said, the solution will turn a slight pink color that lasts for approximately 30 seconds. But to ensure this, the slight pink color, you'll know you're getting close to the endpoint because it'll start turning pink and then that'll disappear right away, and then it'll start turning pink and it'll take a little bit longer to disappear. So you just keep swirling it and waiting so that you know it's disappearing, and just as you feel like it's getting closer to about 30 seconds, that's when you have to be like super careful. So next we have pre-lab questions. So the first pre-lab question that we have is to write a balanced chemical equation for the reaction between solutions of sodium hydroxide and the acid that we're using in this procedure. And a little note is that the ions formed are K+, H+, and CaH4O4 2-, and these are all aqueous because they're in solution. So the answer to this question: first we have the two reactants on the reactant side. So we have the acid KHCaH4O4 plus the base, which is sodium hydroxide, and these react to form the products salt and water because, as we know, acids and bases form salt and water. So this is a double replacement reaction. We have KNaCaH4O4 plus water as our products. The materials that are needed for this procedure include potassium, hydrogen, phthalate, which is the KHCaH4O4 that I've been talking about, the 250 milliliter Erlenmeyer flask, phenolphthalein, which is the indicator that's used to know when it's reached the endpoint for the titration. Then we have a 50 milliliter burette and the stopcock that is also needed for it. Deionized water, a funnel, a 5 milliliters of NaOH solution, graduated cylinder, and a balance to measure the mass.
After you've collected all your materials, you will then go through the procedure of the lab. In this, we will demonstrate the technique. So the first step is to prepare the primary standard acid. To do this, you measure approximately 0.5 grams of the potassium hydrogen phthalate and place it in your Erlenmeyer flask. It's alright if your mass isn't exactly 0.5 grams, but be sure to record the exact mass. Step 2 is to dissolve the acid in 50 milliliters of DI water and add 2 drops of the phenolphthalein indicator. It will take approximately 20 or 30 seconds for the acid to completely dissolve, so continue swirling the flask until it does so. And do not forget to add the 2 drops of the indicator, otherwise you won't be able to see the color change as the lab continues. Step 3 is to prepare the burette. In order to do this, you must first rinse the burette several times with DI water. And after that step, you then rinse it with an NaOH solution 3 times to make sure the inside of the burette is wet with the NaOH solution. You can just label a beaker with the label waste and use that to collect all of the solution coming out of the burette while you're rinsing it. And all waste may go down the drain as the lab states. Step 4 is to fill the burette. So you will fill the burette with NaOH solution, including the tip of the burette at the bottom. After 10 or 15 seconds after any air bubbles have reached the top of the burette, you read the volume so that it's not altered by any air bubbles that may be there. Record it using the bottom of the meniscus. Be sure to be reading it at eye level so you're not inaccurately reading the volume, and record that volume. It's also easier to see how high the meniscus is by placing an index card behind the burette to clearly see it. The next step is placing the Erlenmeyer flask. This is the same Erlenmeyer flask that contains the acid solution. You should put a white piece of paper under the flask because it helps. It's very helpful to see the color changes as you titrate the acid. And you just have to make sure that the opening of the flask is under the tip of the burette so you're not spilling.
For the next step, you want to begin to titrate the primary standard. To titrate the primary standard, you're going to start by opening the stopcock and quickly adding the sodium hydroxide solution to the KHC8H4O4 solution. You're then going to want to swirl the flask to get a proper mixing. Then you want to stop adding the titrant when a pink color forms. You're going to want to record your final volume of the NaOH in the burette somewhere to have in mind later for further calculations. This is now about a rough estimate of how much titrant that you'll actually need to neutralize your acidic solution. For the next step, you're going to want to refill the burette with NaOH and then record your initial volume. Then you're going to want to carefully titrate the primary standard. To carefully titrate the primary standard, slowly add the NaOH solution from the burette to the acid sample prepared as described in steps 1 and 2. Initially add the NaOH quickly until you reach a volume of 2 to 3 milliliters less than the rough volume you obtained in step 6. Swirl the flask to get a proper mixing of the rough samples. Then add the NaOH slowly so as to not pass the endpoint. As the endpoint nears, the color fade of the indicator occurs more slowly. Occasionally rinse the walls of the Erlenmeyer flask with water from your wash bottle. The end point should be a slight pink color that lasts for about 30 seconds. So just because it's over doesn't mean that that won't be the actual end point. For the next step, for step 9, you're going to want to record the final volume of the NaOH in the burette. Once this is done, you have your first trial completed. So then you're going to want to repeat the steps that are necessary for the other trials. Our data from our lab is shown here, and what you want to record for your data in a data table, you're going to want to have the exact mass of your potassium hydrogen phthalate, your initial volume of NaOH solution, a rough estimate of how much titrant will be needed, and a final volume of NaOH in the burette.
Lastly, you're going to perform calculations with the data that you determined so that you can use this technique of titration to determine the concentration of the unknown solution. So to review the calculations, you want to calculate the molarity of the base solution based on the data from part A of the experiment. So you're going to use the mass of the acid and the molar mass of the compound to find the moles of the acid that you have. And then you use the balanced chemical equation to convert moles acid to moles of base. And then you put these moles of base over its volume to find the molarity. And that's how you find the concentration of the unknown solution. So to determine the moles of acid, you have 0.51 grams for my lab data. That's what we determined. But yours will be different depending on how much mass you measured out in the beginning in step 1. So we have 0.51 grams of the acid, and we put that over the molar mass of the acid, which is 204.23 grams. And that's the molar mass, so that's in 1 mole of acid. Therefore, we found that there are 0.00249 moles of the acid in 0.51 grams. So that's how much acid we had. And to find the moles of base, we have the chemical formula balanced equation laid out. And we determined there's 1 mole of the acid in 1 mole of the base, as you can see by the coefficients when it's balanced. And so when you convert the moles of acid to the moles of base, you then get the same amount of acid as you do for base, which is 0.00249 moles of the base solution sodium hydroxide. So to find the milliliters volume of the sodium hydroxide solution, you subtract the initial volume from the final volume. So for our data, we had 22.8 milliliters final volume. The initial volume was 1.85. So we did 22.8 minus 1.85, and that gave us 20.95 milliliters of NaOH. So that's the volume of the base. And then you use that to calculate the molarity of the base, because now you have moles and you have liters, and that's what molarity is. So we put moles over liter 0.002497 moles NaOH from the previous calculation over 20.95 milliliters from the calculation we just did. And then we converted the milliliters to liters. So there's 1,000 milliliters in 1 liter, and when we plug that in, we got 0.1192 moles over liters of NaOH. So that's the molarity, that's the concentration. And so I hope that shows how you can find the concentration of an unknown solution using a known solution. So the known solution was the acid, and we just determined the concentration of the base to be 0.1192. So thank you for watching.